All right, in this video, we are now ready to start solving equations. The addition property of equations says that we may add or subtract on one side. Whatever we do on one side, we can do on the other. So as we grow in our equations from easy to more difficult, we're going to follow the addition rule, which says if I want to move something to the other side, I simply will add the opposite. What you do on one side, you must do on the other. Though we can solve this in our head, I'm sure there's a method that I want you to use, and that is this. Our job is to isolate the x. That means to move anything, any number that's on the same side of the equal sign as the x over to the other side. Now, this is a -5 or -5, and so if I want it to move to the other side, I need to add the opposite. And you remember in the past we talked about additive inverse, which is nothing but the opposite. The opposite of a -5 is a +5. So I'm going to do a +5, and you know the -5 and a +5 are going to clear out. So I added 5 to this side, and I'm going to add 5 to that side. X is now equal to 8 plus 5, which is 13. On our next one, I have x plus 14 equal 20. If you want to isolate the x, you need to tell the 14 to get on over to the other side. You do that by adding the opposite. The opposite of a +14 is a -14. This, of course, will clear out, and that's what we want to happen. And what we do on this side, we'll do over here. I now have a 20 minus 14, or you can say 20 plus, since we're doing the addition property, 20 plus a -14. And since I have more positive than negative, the answer is going to be x is equal to 6. On our next problem, x minus 2 equal -4, you know that we want to move the -2, and the opposite of a -2 is a +2. So I'm going to do +2 to clear and a +2. But a -4 and a +2 makes what? It makes a -2. So as we work these problems, our goal is going to be to move the number that's on the same side as x to the other side by adding the opposite. So let me give you some more problems. Okay, let's try this one. Let's say that I have a -11 equal 3 plus x. Now, it doesn't matter what side the x is on, I still need to move the numbers away from the x. So in this case, I have a +3 that needs to move to the other side. How am I going to make that happen? By adding the opposite. So a 3, add to it a -3 will clear this, and what I did here, I must also do over here. So x is now equal to negative and more negative, whole bunch of negative, -14. Okay? Okay, let's try this one. Let's say that I have a -8 equals 8 plus x. Now, here's the equal sign. You know who needs to go. That's right, that 8 needs to leave and go to the other side. So that's a +8. I'm going to add the opposite, which is a -8. That clears. And I'm going to add a -8 over here. And a negative and a negative, add is a whole bunch of negative, -16. So x is a -16. Now this is pretty easy. We're just using the addition property for equations. Let's try this one. Okay, I'm trying to fool you on this one. I'm going to do a -x equal 14. Now, there's nothing to move. Everybody's on the proper side, but I have a -x or a -1x equal 14. And I don't solve for negative numbers. I solve for positive x or q or z, but I don't solve for negative x. So what we're going to have to do is we're going to have to divide both sides by the number of x's we have. And we have 1, and he is negative. So I'm simply going to divide both sides by a -1, because a negative into a negative makes a positive x. And a -1 into a positive 14 makes a -14. So there wasn't any movement taking place here. I just need to solve for a positive x, and I didn't have one. And when you don't have a positive x, or you have more than x, you have to divide by the number of x's you have and carry the sign. I divide by -1 because we had -1x. So that problem is finished. X is equal to a -14. All right, let's try this one. We'll do a decimal now, but that's not going to make any difference. We're going to go x minus 2.5 equal 4.8. Now, we moved whole numbers over, so we can move decimals over the same way. The opposite of a -2.5 is a positive 2.5, which clears out. And over here, I add 2.5. They're both positive. So the answer is going to be, looks like 7.3 to me. Positive 2.5 on both sides. Okay? So we can do whole numbers and we can do decimals. Let's do one more decimal. Let's say that I have 1.8 on this side, and I have x right here, and 7.9. Okay, now who are we going to move here? We're going to move the 7.9 to the other side because x is on the right-hand side. Okay, 7.9, move it. Well, let's take away 7.9. That clears. And let's take away 7.9. Well, I don't usually subtract that way, so this is what I'm going to do. I know I've got more negative, so I know the answer is going to be negative, so I'm going to put 7.9 on the top. I'm going to subtract 1.8, and it looks like I'm going to get 6.1. But there was a lot more negative than positive, so the answer is going to be x is equal to a negative 6.1. That sounds pretty good. Okay, now we've done whole numbers and decimals. Let's do fractions now. Okay, I think we shall do x plus 1/3 equal 2/3. Now everybody gets crazy when they see fractions because they're afraid something horrible is going to happen. We're going to do the very same thing we've been doing. I want to tell the 1/3 to move to the other side. How do I do that? Adding the opposite. So I'm going to take away 1/3 to clear him out. And I'm going to come over here and go minus or take away 1/3. Well, the good news is that we have a common denominator. So 2/3 minus 1/3 is 1/3. So x is equal to 1/3. So we're still using that addition property for our equations. Just move the opposite to do it to both sides, and you've got your answer. All right, I think we need to try another fraction or two. Okay, how about this one? I'd like to do 1/2 plus x equal 7/10. Okay, now the 1/2 needs to leave. So I'm going to do a negative 1/2 or minus 1/2 on both sides. Negative 1/2 to clear. And over here, I'm going to do a negative 1/2. Now that says 7/10 minus 1/2. Well, let me write that this way for you. 7/10 minus 1/2. In this case, you need a common denominator. And the common denominator for 2 and 10 is in fact 10. So I'll rename that. And then if you recall, 2 into 10 is 5, and 5 times 1 is 5. Now you can subtract. 7/10, take away 5/10 is 2/10. And if we're going to get particular here, we also need to reduce that, don't we? 2 will go into both of those. So 2 into 2 is 1. 2 into 10 is 5. The answer is 1/5. All right. I think we shall try one more fraction. Okay, this time I'm going to do 2/9 plus x equal, well, I think maybe 5/8. Okay, now who's moving? We don't want to move the 5/8 over to the left-hand side. We want to move the 2/9 to the other side so x can be by itself. So opposite of 2/9 is a negative 2/9 to clear, and a negative 2/9. Now we're probably going to need a common denominator there. So let's write it top down. 5/8 minus 2/9. Common denominator is what? 72. 8 into 72 is 9. 9 times 5 is 45. 9 into 72 is 8, and 8 times 2 is 16. Okay, we're ready to subtract. So we'll go bar over here. 15 take away 6 is 9, and 3 take away 1 is 2, and we now have 29 over 72. So x is equal to 29 over 72. All your answers are not going to turn out to be whole numbers. Plenty of times you're going to have fractions, so don't be bothered by that. As long as you can't reduce it any further, you're finished. All right? Now, let's do just a few more. Okay, I want to show you this. I want to keep this in front of you, because as we start solving equations and they get a little more difficult, we need to keep in mind these top issues. Number one, if there's any distribution, we need to do it first. If there is no distribution, then we need to combine our terms, whatever terms on the left-hand side, whatever terms on the right-hand side. Once we combine everything, then we can isolate the x, the variable, and solve the equation. So I'm going to force that on you here right now. All right, here we go. I'm going to go 2x plus 3x minus 4 equal 8. Now, I know that I want to move the negative 4 to the other side. I do. But until I combine my like terms, we don't need to be doing that. Let's go ahead and combine and rewrite the problem. We have a 2x and a 3x for 5x. So I'm going to write 5x minus 4 equal 8. Now that I've got my terms combined, I can in fact move the 4 to the other side. So I'm going to do a plus 4 to clear and a plus 4 over here. I now have 5x is equal to 12. Now, let's look at this. In the past, I've been having just x's, or negative x, but now I've got 5x. That's like 5 people want to share 12 cookies. It ain't going to happen. We have to divide, always divide by the number of x's you have if you have more than one positive x. So at this point, I'm going to have to divide both sides by the number of x's I have. And 5 into 5 makes x, or 1x, and 12 over 5 is the answer. Now, we don't really have to turn it into a mixed number. Can if you want to, which would be, 2 and 2/5. So if we're dealing with cookies here, 5 people are going to get 12/5 of a cookie, or they're going to get 2 and 2/5 of a cookie. And that's okay. So remember, we're going to distribute if we need to, then we're going to combine like terms, then we're going to isolate the variable, and then at the very end, if we don't have a solid variable that's a positive 1x or whatever the variable might be, we're going to have to divide by the variable that by the number of the variable that we've been given. All right? So let me try one more on you. Okay, this time I'm going to do a negative 23 plus 6 equals 6x plus 4 minus 5x. Now we have a lot of combined like terms to do here. On this side, we can combine our numbers, a negative 23 and a positive 6. That's going to be what? Negative 17. Okay, negative 17, we took care of that. Now on this side, I have a 6x and a negative 5x. Okay, let's combine those into just 1x and then the plus 4. Now that I've got everybody combined, I can move. Who am I going to move? I'm going to move that 4 right there to the other side because he needs to get onto that other side so x can be by himself. So 4, let's move. I'm going to add a negative 4 to clear it, and over here I'm going to add a negative 4 as well. So 1x or x equal negative, and more negative is a whole bunch of negative. X is equal to a negative 21. So what we've done so far is using the addition property for equations, we have solved several different types of equations. And that'll take care of it for this one.